Welcome back, ladies and gents. In today's video tutorial, I'll be looking at 7.3, the double angle formulae for trig. Let's start off with the double angle formula for sine. So I have that sine 2a is equal to 2 sine cos. Okay. What I do is I take the angle 2a and I half it. I get a over here and a over here. This is true for any a. Let's have a look at some crispy examples. The first one is sine 4 theta. Well, that they're using the double angle formula for sine is equivalent to 2 sine cos. I take 4 theta, I half it, I get 2 theta. Another example, if I have something like sine 60 degrees. Well, sine 60 degrees, if I use the double angle formula for sine, is equivalent to 2 sine cos. Take 60 degrees, half it, 30 degrees. One more example. Suppose I had maybe sine x, okay? Using the double angle formula for sine, this is equivalent to 2 sine cos. I take the angle x and I half it, so x over 2. And there you have it. That's my examples on applying the double angle formula for sine. Let's have a look at the double angle formula for cos. So I've got cos 2a equal to, there are 3 different representations. The first one is cos squared minus sine squared. I take the angle 2a, half it, a. There you have it. The other representation is in terms of cos. So I've got 2 cos squared minus 1, half the angle 2a, a. Okay? The last representation is in terms of sine. So I have 1 minus 2 sine squared. Take the angle 2a, half it, a. Okay? So I've got 1, 2, 3 different representations of the double angle formula for cos. Each of them are true for any a. So let's have a look at some examples. The first one is, I want to work out cos 8 theta. In terms of cos and sine, if I want to work out cos 8 theta in terms of cos and sine, I'm going to use representation number 1 because it has a cos and a sine. So I can write cos squared minus sine squared. I take the angle 8 theta, half it, 4 theta. 4 theta. There you have it. Okay. Suppose I want to find cos squared theta in terms of cos. Well, in this case, I'll be using representation number 2, okay, where I need to make cos squared the subject. So, if I make cos squared the subject using representation 2, I get the result cos 2 theta, okay, plus 1, all divided by 2. Okay. One more example. Suppose I want to write cos 10x in terms of sine. In this case, I'm going to use representation number 3. I can write 1 minus 2 sine squared. Take 10x, half it, 5x. Now, let's have a look at the double angle formula for tan. Okay, so I've got tan 2a is equal 2 tan a over 1 minus tan squared a. Let's have a look at some examples. The first one is tan, let's say 6 theta. Well, tan 6 theta will just be 2 tan over 1 minus tan squared. Take the angle 6 theta, half it, ladies and gents, you get 3 theta. One more example. You could have tan x, okay, that's equivalent to 2 tan over 1 minus tan squared. Okay, take the angle x, half it, x over 2. And there you have it. That completes my examples on using the double angle formula for tan. Let's have a look at question number 1. It says find the possible values of sine theta when cos 2 theta is equal to 23 over 25. Now, we've got the value of cos 2 theta. It is 23 over 25. The target is to work out the possible values of sine theta. So when I go back to my double angle formula for cos, I've got representation 1, 2 and 3. The one that I need to use is number 3. Okay, because number 3 is cos 2a in terms of sine. And I need to work out the value of sine. So I start off by writing cos 2 theta is equal to 1 minus 2 sine squared theta. I can substitute my cos 2 theta, which is 23 over 25, into this equation. I get 23 over 25 equal 1 minus 2 sine squared theta. Now, ladies and gents, I would like you to solve this particular equation for sine theta. Once you've got your solution, the answer will come up on the board. Okay, so once you have finished, you should all obtain sine theta equal plus or minus 1 over 5. Let's have a look at question number 2 now. Given that theta is more than pi but less than 3 pi over 2, find the value of tan theta over 2 when tan theta is equal to 3 over 4. Now, this is a very interesting question. We will need to either apply the double angle formula on the tan theta over 2 or the tan theta. Let's start off by applying the double angle formula on tan theta over 2 and see what happens. So, tan theta over 2 is equivalent to 2 tan over 1 minus tan squared. I take theta over 2, ladies and gents, and I half it. I get theta over 4. Okay, there you have it. Right. I need to work out the value of tan theta over 2. That's my target, but I don't know the value of tan theta over 4. So I can't really work out the value of tan theta over 2. So I shouldn't really apply the double angle formula for tan on tan theta over 2. Perhaps I need to apply the double angle formula for tan on tan theta. Let's have a look what happens. Tan theta equal 2 tan over 1 minus tan squared. Well, I take theta and I half it, theta over 2. Okay? This is looking much better, guys. I know what the value of tan theta is. Tan theta is 3 over 4. So I can put 3 over 4 into this equation and then solve for tan theta over 2. I would like you all to put tan theta equal 3 over 4 into this equation and then rearrange to work out the value of tan theta over 2. Have a go, ladies and gents. Okay, after solving, you should all end up with tan theta over 2 equal 1 over 3 or tan theta over 2 equal minus 3. Now, the next step is to look at the angle very carefully. Over here it says theta over 2. So what I need to do is go back to my interval for theta and half everything. Okay, so if I do that, I get pi over 2 is less than theta over 2, which is less than 3 pi over 4. So if I look at my class diagram, CAST, that's 0, pi over 2, pi, 3 pi over 2, 2 pi. I see that the interval is theta over 2 is more than pi over 2, but is less than 3 pi over 4. Okay, so the angle will be in the S quadrant. And in the S quadrant, only sine is positive, the rest is negative. Hence, I need to take this value for tan theta over 2, which is the negative 3. That there will be my answer. Okay guys, let's have a look at question number 3 now. It says, given that 4 cos 2x is equal to 6 cos squared x minus 3 sine 2x, show that cos 2x plus 3 sine 2x minus 3 is equal to 0. Okay, this particular question is looking somewhat tasty. There is some spice in this question. I'm going to actually give it a go and taste the question. So, what do I do here? Right, what I need to do is start off with this equation, manipulate it, and end up with this equation. My first observation is that there is a cos 2x here, cos 2x here. Second observation, there is a sine 2x here, sine 2x over here. Third observation, there is a cos squared x in this equation, but no cos squared x in this equation. So what I need to do is eliminate the cos squared x in this equation. Right, I'm going to start my working out. Start off with this equation over here. So 4 cos 2x equals 6 cos squared x minus 3 sine 2x. Now, I say to myself, how do I eliminate the cos squared x? Well, all I need to do is apply the double angle formula for cos, and the one that I'm going to use is representation number 2, because it's got a cos squared involved and no sine. Okay, so using representation number 2, modifying it, because over here you've got a's, I can modify that and write cos 2x is equal to cos squared x minus 1. Over here, what I need to do is make cos squared x the subject. Okay, so if I make cos squared x the subject, I can replace the cos squared x with cos 2x plus 1 divided by 2. Now all I need to do is expand and simplify this, take everything to one side, and I should end up with this result over here. So I'm going to quickly do that. And there you have it. I've got the equation that I needed. Cos 2x plus 3 sine 2x minus 3 equal to 0. If you found this video tutorial useful, please don't forget to subscribe.